Hello Math 1093, this video is about how to translate between radian measures of angles and degree measures of angles. I know that degree measures are probably more familiar to most of you, but in this video I hope you'll find that translating between the two doesn't have to be that much of a chore if you know a couple of really important facts. Alright, so just as a reminder real quick, I just want to remind everybody that if I have a circle like this one, then an angle of measure 1 radian, so measure 1 radian, that is the angle that sweeps out an arc whose length is 1 radius length. And I'm sort of guessing in this picture at what the right length is, but I think that's about 1 radius length. Okay, and one thing I didn't mention in the previous video is that 1 radian, it looks like it's about 60 degrees, but it's not quite. It's about 57 degrees. Okay, not exactly. That's just an approximation. Alright, so anyway, in this video we're going to talk about how to go between certain radian measures and certain degree measures that are very familiar to us. Alright, so I'm going to put another picture of a circle in this in the field of play here. There we go. Okay. Yeah, so let's talk about this circle now. So suppose that I draw an angle that sweeps out half of this circle. Okay, so a straight angle. That angle, you probably know that its measure is 180 degrees. But we can also state it in terms of radians, the measure of this angle. The way that we do that is we measure out how many radius lengths are there along this semicircle. Sorry about the crappy drawing. That's supposed to be the semicircle there. Okay, how many radius lengths is this? How many radius lengths? Well, in the last video, we talked about the fact that a full circumference is 2 pi times the radius. So a semicircle is pi times the radius. So this length is equal to pi times the radius. That's pi radius lengths. So because this arc has length pi radius lengths, the measure of this angle then, that's going to be pi radians. So those two things are equal, 180 degrees and pi radians. Alright, so now there's going to be some other angles whose measures we're going to need to know in both degrees and radians. And it's going to turn out that all of them, more or less, we can figure out using this one fact, the fact that 180 degrees is equal to pi radians. So let's keep that fact in mind as we proceed here. I'm going to move over and put in another circle. Okay, there's going to be a lot of circles in this video. Alright, so here's another circle. Poof. Okay. I'm going to move that over. Alright. So now, let's draw a different angle. The different angle I'm going to draw is the one that starts here and ends here at due north. By the way, each of the angles I'm drawing is in standard position. Standard position just means that the starting leg of the angle is on the positive x-axis. Okay, so in this case, I'm talking about this angle here. Alright, let's just put this in a coordinate plane where this is the x-axis and this is the y-axis. Drawing straight lines, by the way, is really hard in using this tool. So I hope you appreciate how well I've done here. Okay, so anyway, that's in standard position there. So was the previous one, by the way. Both of these angles are in standard position. Okay, anyway, what's the measure of this angle? Well, you probably know that the measure of this angle is 90 degrees. You're probably familiar with that. But what is it in radians? Well, I know that this angle here is pi radians, so that's pi. And what I'm doing is I'm just chopping that angle in exactly half, 2 equal parts. So this is pi over 2 radians. By the way, one other way of saying this, it's equivalent, but sometimes I like to say 1/2 of pi, just so I'm emphasizing this is a fraction of pi. It means the same thing as pi over 2, it's just a different way of saying it. Okay, so that's 1/2 of pi radians. Okay, let's do another example. Like I said, lots of different circles going to get created here today. Alright, so here's another one. Alright. Alright, now I'm going to draw a diameter again, just to split this circle into half. Okay, so there's the diameter. Okay, now suppose I take this semicircle, the top semicircle, and divide it up into wedges where each wedge has an angle of 60 degrees. Okay, that's pretty good. So I'm dividing this into 3 equal parts, this semicircle. Now you remember, the semicircle, that angle there, that straight angle, has a measure of pi radians. So what's the measure of one of these angles? Well, I've split those pi radians into 3 equal parts. So this is 1/3 of pi radians. And so is this angle here. This angle, by the way, is in standard position. This is a little bit hard to draw without interfering with what I've written already. So I'll draw it in a different color. So that angle there is 1/3 of pi radians. And that's equal to 60 degrees. Because 180 divided by 3 is 60. Okay, so 60 degrees is 1/3 of pi radians. All right, now again, I'm just using the fact that 180 degrees is equal to pi radians. That's the only fact that I have to remember. Everything else I can do using fractions. All right, one more. Actually, 2 more. Sorry. All right, here's another circle. Suppose I take my semicircle, my diameter, and now I split this semicircle into wedges where each wedge has a central angle of 45 degrees. There we go. Sorry, my lines are going a little bit astray here. All right, so what is the measure of this angle in radians? Well, a semicircle, that corresponds to an angle measure of pi radians. That was pi radians. And what fraction is this? Well, this is going to be 1/4 of that because I've divided that semicircle into 4 equal chunks. So this is 1/4 of pi radians. And the angle measure is 45 degrees. So I know that 45 degrees equals 1/4 of pi radians because I took 180 degrees and divided it into 4 equal chunks. It's 45 degrees each. All right, one more, and then we're done. All right, so let's suppose I take this semicircle and divide this into sectors where each sector has an angle of 30 degrees. I'm doing this as best I can here. I'm just sort of freehanding it. There we go. Doing this on a tablet is kind of tough. All right, so what is the measure of this angle? Well, I've divided pi radians into 6 equal parts. So this should be 1/6 of pi radians. And what's the angle again? Well, I've taken 180 degrees and divided it into 6 equal parts. So that is 30 degrees. 30 degrees. So that means that 30 degrees is 1/6 of pi radians. All right, so now what if I'm given just some random angle measure in degrees and I want to change it over to radians? Let's talk very briefly about how to do that. All right, so suppose I'm given some angle whose measure is k degrees, and I want to know how many radians that is. So let's call that x radians. All right. Well, what do I know? I know that 180 degrees is equal to pi radians. So what would 1 degree be? Well, 1 degree is just 1/180th of that. It's 1/180th of pi radians. I'm going to go ahead and write that a little bit more compactly as pi over 180 radians. So if I want to know what k degrees is, then I should just multiply all of that by k. So k degrees should be k times pi over 180 radians. Okay, so let's try this out on a degree measure that we know about. Let's say 30 degrees. 30 degrees should be 30 times pi over 180 radians. And if you simplify that, then you get 1/6 of pi radians, which is the same thing we got before. So that's nice. Okay, what if you want to convert a certain number of radians to a correct number of degrees? How would you do that? Well, let's start with this fact again, that 180 degrees equals pi radians. And let's start a bit differently now. What happens if I divide that by pi? Well, then that would tell me that 180 degrees over pi, or 180 over pi degrees, that would equal 1 radian, because I should be able to divide both of those equivalent measures by pi. So if 1 radian equals 180 over pi degrees, then x radians should equal this 180 over pi times x degrees. So those are formulas for converting between degree measures and radian measures. All right, I know I promised I would talk about linear and angular speed, but I think I will just do that in class since we're running out of time to post new videos for the next lesson. So I'll see you in class.